Mr. Yeah. The beginning, I said, what a great day to start the series, because today is Feb 28th, is National Science Day, and pleased to start uh, the discussion, the webinar series with our 4-year BSc in Chemistry program. Of course, Science Day is not only about sciences; it's about scientific temper. And my colleague Ahana and other colleagues will lead the discussion. I'm not going to read their profiles in the interest of time. You should look up. They're all scientists, and particularly Ahana has worked as a scientist in the US before uh, joining us in Cambridge University. And you can see from where they have done their master's and in fact a PhD from Princeton. So with that, I can say some interesting caricature there. Over to you, Ahana. And we will come in if there are questions on admissions. But today is to understand chemistry as a central science. Over to you.
Okay, thank you. Can you hear me?
Very clear.
Okay, right. This is more or less kind of meant for students who are basically considering studying chemistry, and more specifically considering studying chemistry at our university, the Azim Premji University. And so, the two kind of cartoony pictures that I've put up is basically probably a question that, some of you are asking yourselves, or some, your family members are asking you, or your parents are asking you, is why do you want to study chemistry, right? Apart from the fact that perhaps you basically love the subject, right? What is the point of studying chemistry, right? And there are, of course, lots of different reasons to study chemistry, but two things, one of the things that that you were looking at, which I was talking about in the video, is that right from when, we as humans started to use fire, we've been chemists. And right now, if you just look around you, in the room around you, you'll find all these objects that you use every day, including the display, right, that I'm looking at you through, or that you're looking at me through. All of this, basically, there's a huge amount of chemistry behind it. And essentially, chemistry is the science that kind of makes our bodies run, that makes up the air around us, right? And understanding all these components of your life is basically why anybody would study chemistry. It contributes to so many other sciences, right, in so many different ways, physics, biology, botany, astronomy, medicine, right? Because of this, it's sometimes called the central science. So with your study of chemistry, you can basically think about a lot of different kind of careers, right? And I think that's important to consider, apart from what you find interesting about chemistry. What can I do after college if I study chemistry, right? You can go into more conventional jobs that you've probably heard of before, right? Like you can become a professor like me, you can become a research chemist like I used to be, right? You can become a material scientist, you can, but then there are also all these non-traditional jobs that probably you don't think of as a chemistry major that are kind of available to you. Now, when we have designed the curriculum at our university, at Azim Premji University, we've kept all these different kind of possibilities in mind, right? So all of these different possibilities in mind have gone into kind of designing a curriculum that enables you to have the widest range of options possible for your future as a chemistry major. Okay. Let me talk a little bit about how we teach and what we consider the most important kind of highlights of the way we teach. So the first thing is that, when we are a new program, as you know, we started last year, right? And when we kind of started, we had a few things in mind in terms of, sorry, my slides are not transitioning. Just give me a minute. Yeah. Yeah, so we basically thought that, what were the important things that a chemistry student today should know and should be able to do after they graduate, right? And one of the first things was we thought that, you know, unlike how maybe many of us studied chemistry, or maybe many people are still studying chemistry now, which is just from the textbook, and memorizing a whole lot of different reactions, a whole lot of different laws, solving a lot of numericals. We thought, no, that's not how we want students to study chemistry. We want them to have research skills and experimental skills right from day one, right? So the first course that you do in our curriculum, and the second and the third course, and all of the courses that you do in the first year and second year, they basically have a lot of experimental work in them. You do experimental projects, not just labs. You do experimental projects right from day one. So the students who are doing a chemistry course with me right now, which is called Introduction to Chemical Thinking, are using techniques like infrared spectroscopy and all of that on their own in the lab. And those are techniques that I did not use until I was in my MSc, right? So I did not use those techniques on my own till I was actually doing my master's, but our students are doing that right from the first year. The second important thing is that you are learning chemistry in a world where chemistry is applied all around you, right? So the first course in the curriculum is called Chemicals in the Community. It takes the things that you have already somewhat learned in high school, right? You've learned about the periodic table, you've learned about atomic structure, you've learned about chemical bonding, you've learned about all these different forces between molecules like hydrogen bonding and things like that. It takes all these topics and applies them to actually things to areas in which they are applied in real world research. So for instance, you may have studied protein structure in school, right? But Chemicals in the Community shows you how the knowledge about protein structure, and even the knowledge that you already have as a first year student, is being used to develop medicines, for example, right? To do drug design and drug development, right? Or the knowledge that you already have about the periodic table, how you can apply to understand materials like this indium tin oxide, right? Which is in your cell phone display, which makes the display touch screen, right? So it is important for you to know right from the beginning that as a chemist, right, in the first, as a chemist, later on in your career, there are all these different fields to which you can make very, very important contributions, right? Later on in your life, after you study chemistry, right? And that brings me to my next point, that how do we actually, and this is important for you to know because you are at a kind of juncture in your life where you're trying to decide what to study, and you should know a little bit about what that means, what you study means for your life later on, right? And in our case, we haven't really assumed that just because you are studying chemistry now, you will do masters and PhD in chemistry later on. So you see on my list, if you can read, I've listed a whole bunch of different things. Okay. So I have listed, of course, the most conventional career path, which is that you do a master's and a PhD and you do research in some field. I've listed employment in chemical industries that use chemistry. And of course, India, as you may already know, is a huge hub for pharmaceutical industry, pharmaceutical manufacturing. Just where I'm sitting today, Bangalore, is a huge hub for a lot of very, very good pharmaceutical R&D and pharmaceutical manufacturing companies. Okay. So you have all these chemical manufacturers as well. And agrochemicals, that means the production of fertilizers, pesticides, herbicides, all these different kinds of things. And then, of course, you have a whole host of careers that one doesn't really think about, right? Like science journalism and writing, intellectual property law, right? So if somebody develops a new compound, right, how do they kind of claim the intellectual property, right? And what does that mean for society, right? And then, of course, higher education and non-science programs. So we have a lot of flexibility built into our curriculum and our structure that you can actually look up on the website. You can see all the different kind of courses that you will do. And you'll see that for higher education and all, we have lots of advanced courses. Advanced, by advanced, I mean advanced for the BSc level. Okay. So because it's a 4-year program, we have the space to offer you these advanced courses. And that prepares you perfectly for higher education. But it also prepares you perfectly for, different employments in different industries. So if I was to use a small example, suppose after college, you want to basically get into a job in a pharmaceutical company, say something like Dr. Reddy's, right? You want to basically make an impact in the world by working on drug research, right? On designing medicines, right? So in those kinds of jobs, right, you need to know how to look at how to do certain experiments. Like you need to know how to do chromatography, you need to know how to do some other kinds of advanced experimental techniques. We teach that in our courses, right? So not only in our advanced electives, but in the laboratory experience that you end up getting, we teach that. We also have, very importantly, we have included computer programming in all of our courses. Not in all of our courses, but all of our mathematical courses, right? We've included computer programming. So you get, even as a chemistry student, you learn how to read Python code, write Python code, read a basic computer program, learn its structure, so that you become capable of analyzing very, very large amounts of data, which is important for any industry, but it has become a very important skill for the pharmaceutical industry, right? So we have kept all of these skills that you need in mind while designing the curriculum, right? And then, of course, we have these occupational tracks in areas that actually leave an impact on our society, right? Like we have occupational track in climate studies, right? We have an occupational track in education. We have an occupational track in development, data science, right? And then you can also take minors in other subjects like environmental science. And advocate for environmental causes. And because you're a chemist, you understand the science. So you are very, very well equipped to write about it, to explain it to other people, right? And to kind of study the impact that all these things, all these human activities have on the environment, right? You have the capacity to do that. You have the capacity to write about science, right? So we have an occupational track in media and journalism, for example. If you do an occupational track in media and journalism, along with your chemistry degree, you're very, very well prepared for a career in science journalism. So we've kept all of that in mind, along with the flexibility in our 4-year curriculum, to kind of design something that allows you to do a lot of different things after graduating. And you are not just tied to doing a master's and a PhD, okay? Which is also, of course, something that we enable, but it's not just that. Now, how do we kind of do all of this, right? We do all of this basically, by designing a curriculum that, of course, takes into account all the flexibility. But even within our chemistry curriculum, right, instead of, teaching chemistry like how you would have learned it in school, where you need to by heart a whole lot of content, a whole lot of reactions, just simply to learn chemistry. We don't believe that that is how chemistry should be learned. So instead of teaching you what chemists already know, right, we teach you how chemists think, right? The second and third course that you do in the chemistry program are actually called Introduction to Chemical Thinking 1 and 2. right? Where we are basically telling you about the basic rules and the foundational concepts of chemistry that help you understand all other kinds of chemistry later on. And you're not simply relying on by-hearting and memory work when you're studying, right? So you can broadly think of what we teach you as being divided into this category of structure and analysis, synthesis and reactivity, and how models are developed. Okay. And that's how our courses are divided. And all of our courses have very, very strong laboratory components, right? So this is our new lab, which we've kind of, we have four new labs actually, and we've put a lot of effort. And two of the labs are not for teaching purposes at all. They're exclusively for you to go ahead and do research projects, okay? So we have student research labs with quite a few advanced instruments, and we are building that up as we go along, right? We're building more and more advanced equipment so that you can do a lot of research. Our students, the chemistry students are in their first year, but other students have been doing a lot of interdisciplinary research with chemistry. And if there are any questions in the end, I can talk more about the kind of research our students do. But there are, projects ranging from, say, the toxicity of smoke in cigarettes, right? Like basically lung fluid models to study the toxicity of smoke, which is quite an advanced research topic, to something like using plants and fungi to create new chemicals, right? Which can be used for different purposes. So using a fungus to grow a plant hormone called indole acetic acid, or using plants to grow a compound that actually has anti-cancer properties, right? We have students doing all these sorts of things, right? Or if you look at the interdisciplinary field with physics, we have a student who did a project on butterfly wings and studying how the structure of butterfly wings actually makes them have these brilliant colors, right? Which is called an entire field called structural optics, which is based on these nanostructures and microstructures in these wings, right? So all of the student research goes on. And briefly, before I end and take questions, I want to show you the structure of the curriculum, right? So right up to the sixth semester, that is your third year, you're doing all the courses that are actually compulsory. So chemicals in the community is the course that I was talking about initially, where we teach you chemistry through, say, drug development, material science. That means like what is in your cell phone or something like that. Or cooking is a very important part of that course, because you can learn a lot of chemistry through just observing the changes that take place when you cook food in the kitchen, right? Then in the beginning itself, you have two courses called mathematics and computing. And this is like really important to remember, because of course, in all universities, you do math when you're studying chemistry. But we have included computing in our curriculum because, as I said, computer science and programming is a very, very important skill for students of this era now. And no matter what industry you go to, if you have a little bit of programming knowledge, if you can analyze large amounts of data using programming, in your research, in your science, in your materials research, whatever, you are greatly benefited by that. And the earlier exposure that you get to computer science and programming, the later you feel more comfortable using it. So that's why our math course is mathematics, and you do computer programming along with it. And then we have a series of kind of core courses called structure and property relationship, principles of reactivity, thermodynamics. But we also have skills-based courses like inorganic synthesis, chemical analysis and spectroscopy, organic synthesis. These are courses which are almost purely lab-based, where you get to use a lot of advanced techniques hands-on to learn about all these skills that you need to develop for higher education or for your careers later on, directly very early on in your BSc. Okay. And then in the last semester, we have something called research honors, right? So the research honors is a project that you do with a faculty member and you submit a thesis at the end of it. But you can actually start working on the research honors in your second or third year, right? But we have an entire semester in the 7th semester just dedicated to the research honors, so that you have this dedicated time to do some substantive research so that you're very well prepared with experience later on for your master's or PhD or any other career that you choose later. Okay. And we have a whole list of electives that we are planning to offer. And as you can see, these electives I have kind of listed into different buckets or tracks, like synthesis, material science, environmental chemistry, computational chemistry. These are kind of 3 focal points. So if you decide that, later on, you already know you want to do something with synthesis later on, right? You like making molecules, you like synthesizing new chemicals, right? Or if you decide that you like environmental chemistry, you want to know about the impact of chemistry on the environment, you want to study how things work outside in the field, in the environment, how do chemicals behave there, right? If you want to do that, then you can take 2 or 3 courses in this particular bucket, and then you get a concentration in that, right? So this is to help you choose what to study. Okay. So I'll stop here, and then I think, we can take questions about whatever I've said so far.
Yeah, thank you so much. I think me and my colleagues also would have learned quite a lot about the curricular structures. The questions, if any, from the participants, we can take now. Or if Aditi, I'm sorry, I didn't introduce Saswata and Aditi, I saw only later. If there's anything that you want to add, please kindly go ahead. Both of them teach in the BSc Chemistry program. Now we'll take questions. And while we're waiting for questions, just a reminder that the chemistry program or the major is part of the large 4-year liberal education program at St. James University. And Ahana did talk about that, right? You can combine the chemistry with a minor, which what we call an occupational minor of your choice. There's a set of common curriculum courses that all students will go through.
Hello.
Yeah. So if there are questions, you can either add it in the chat or you could ask directly to the faculty. Yeah, Nancy, what's the question? Do you have a question now?
Rajgopal, am I audible?
Yes, very clear.
Thank you, thank you. So, Ahana, thank you so much. It was such a lovely, beautiful presentation. They gave so much of clarity over the course and the relation between the occupational track along with the course as well. I just have one doubt. There are certain related job roles like medical coding in life science companies. Could you just elaborate about that along with the actual coding, what you really spoke about, the computer coding for the chemistry students? I just wanted that difference, medical coding in life science company, along with this. So, what is the exact difference between both?
I mean, there's a huge amount of difference. I mean, so essentially, there is quite a substantial difference between the two things. When we are talking about coding and computer science in a chemistry major, we're basically talking about, learning how to solve problems using computer programming. The same problems that you would solve, say, mathematically using pen and paper, how to solve those problems with computers, and also how to analyze large amounts of data, right? So the point is that you should think about it this way: learning programming in any form at the college level, right, along with your major, is basically like learning the alphabet or learning how to read or to do basic arithmetic. And then that eventually helps you pick up a career in something like medical coding quite easily. right? Because essentially, you see, what happens is whether it is
Or
a sorry, please, yeah, go ahead.
No, 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 no. I
Okay.
think so.
nothing.
Yeah, so essentially when whether it's a pharmaceutical company or what you were talking about, right? I think you were saying, were you life sciences companies, right? So whether you are talking about, yeah, when you're talking about pharmaceutical companies, life sciences companies, we actually, so I used to be with the Food and Drug Administration earlier. So when we were designing the curriculum, we talked to pharmaceutical companies and all of that. So essentially what they want is, students who have a basic amount of skill, I mean, in certain niche areas. So they want people who can read and analyze and write a Python program, right? And then these companies, anyway, because they are so specialized, like life sciences company or pharmaceutical company, they will train you in the specialized skill that you require. So it's important to have a general skill from college education. And then when you go on to the particular job that you want, as long as you have the basic skill, you're well equipped and to be trained and then pick up the particular skill that, is required of you. I would say that.
Yes,
Does
yes,
that
yes,
make sense? I hope that helps.
yes, yes, Ahana, yes.
Yeah.
And so you do recommend the medical coding professionals for chemistry graduates?
I think, I mean, they can go in from any trajectory, but in general, I mean, see, medical coding is a very specific occupation, right? But in general, if people want to do something meaningful in this space, of life sciences companies or in pharmaceutical companies, without being extremely focused at a very early stage on this particular profession, right? Without being focused. But if you want to generally leave an impact in pharmaceuticals, in life sciences companies and things like that, in that kind of research, then the chemistry degree is absolutely the right degree to equip you in the right way. Because all the kind of research chemists, the drug design people, the people who are analyzing genomes and things like that, they tend to have a chemistry background because it helps. It helps you to think structurally when it comes to these things. It helps you to think in terms of molecules and their structures. That's what essentially, a degree in chemistry prepares you to do.
Got it, got it, got it. Thank you, Ahana. Thank you.
Yeah.
So there's a question from on the chat, which I'm going to read out loud. What are the research topics the students are working on currently? So I know the chemistry they would not have reached, but a lot of biology
Yeah.
students I know they
Yeah,
do
yeah, yeah.
interdisciplinary
Yeah, no, I
research.
like that question actually.
Thank you. Yeah.
Yeah. So, well, so I mentioned a few interesting examples. One was this, the toxicology of cigarette smoke, which is you can collect. You see, the toxicology of cigarette smoke. Cigarette smoke essentially has like over 7,000 different chemicals. Okay, and it's like impossible to sit and tell you how many different chemicals a puff of cigarette smoke has. But essentially, you can divide these chemicals up into gases and the particles. And the particles are also the same kind of particle pollution that you see in the air, right? Like when you go to Bangalore and you have bad air quality days, the same particles are there in that smoke. Now, the thing about cigarette smoke or these inhaled particles is that when you inhale them into your lungs, the first thing that happens is that they encounter the liquid in your lungs, the fluid layer in your lungs. So what we are doing is we are making these models of fluids, right? Like a simple chemical component mixture, as well as very complicated chemical component mixtures. And we are studying the chemistry of these particles, mixing particles collected from cigarette smoke or particles that we make in the lab, mixing with this lung fluid, and basically testing it using spectroscopy. So we have spectrometers in our lab. We have IR spectrometer, we have UV visible spectrometer. And these are the kinds of experimental techniques that you need to actually study this toxicology. So the poisonous effect that cigarette smoke would have in your lungs. Then another example that I can use is, for instance, like can we use bacteria to clean up heavy metals from the water. And we are trying to understand the mechanism by which that happens. And that mechanism actually involves a very small molecule that kind of grabs onto metal ions in the water. So it's supposed to actually grab onto iron, but if you have other ions like nickel, cadmium, lead, which are poisonous, actually, it grabs onto those also. So we have that. Then we have another project that I was talking about, which is like the brilliant color of butterfly wings or peacock wings. That was done by a physics student last year. She has graduated and she is actually writing it up for a small article. But essentially, these structures that you have on the wing, they are responsible, they're nanostructures and microstructures. So extremely small structures, they are responsible for these brilliant colors. And those colors we've studied in the lab. I mean, so this student actually, she worked with a physics professor and a biology professor, and she used some of our chemistry lab things to basically, study why the structure gives you this brilliant color. Okay, so there are lots of interesting projects that biology students, physics students are already doing with chemistry. And now chemistry students, they've joined. Yeah. So, I mean, these are just a few examples, right? I think there are some more questions in the
Yeah,
chat.
I think the next question is on chemistry with a B.Ed, right? So the dual degree program. You can start,
Okay.
but yeah, with the way I look at it is the only difference is the chemistry that you learn in the BSc B.Ed program or the 4-year BSc program is the same. There is no occupational minor as a component in the
Can I have a question?
B.Ed program. And yes, and the
Am I
B.Ed
audible?
you are.
Yeah,
I'm
yeah.
just answering in the B.Ed
Please,
program.
Yes,
go ahead.
yes, yes. I'm Juman. I'm from Barmer, Rajasthan. So it's a privilege for me to speak to both of you.
Yeah.
And
What's the question?
also mentioned that these are very much employable in the field of the pharmaceutical as well as some in chemical industries. So what is the scope of employability first in teaching and second in the Azim Premji Foundation, because foundation is also working in the field of the education. So chemistry is the core subject of the education. So these are my two queries. Can you please clear those both one?
Can I just start, Ahana? You could just
Yeah, please.
Yes, yes.
in the sense, because I'm going to combine both the questions that you asked. Somebody was asking about the B.Ed program. See, uh, the best way to understand the outcome of a program is based on what you learn, right? So it's a B.Ed program is structured slightly differently. You're going to
Okay.
study chemistry here in this pillar, what we call the specialization, right? When you get all the skills, capacities, or sensibilities of a chemical scientist, and then in parallel, you are learning education starting from the second year in an integrated fashion, right? So you're graduating with 2 degrees, that of BSc Chemistry and the B.Ed. And when your question is if you want to work with the foundation, depending on whether there's a campus selection process, if there is an opening of a chemistry teacher or a science teacher in the Azim Premji school or elsewhere, then you're entering the job of the of an educator or a teacher. And I'm not talking about the common curriculum now. Now, going back to what Ahana was talking in the beginning, I'm just going to go back in the slides here. The 4-year honors program is designed very differently. Now that depends on, of course, you do chemistry, depends on what kind of a minor you are doing here. That also to some extent will decide which area you want to get into. So I'll stop now. Over to you, Ahana. You can see that. I mean, let me make a very a completely different argument. Somebody may do BSc Chemistry and may do media and journalism, wanting to get into science communication, which is quite weak in the country and elsewhere. So a lot matters, huh? The combination that you do. So BSc B.Ed is a completely different track. 4-year BSc honors is a different track. But Ahana, you can add because you would know about the industry much more than me.
Yeah, so no, Rajgopal, I mean, you explained it perfectly. The BSc B.Ed is a dual degree, right? So it is in some sense a professional degree also, because directly after that, so we've had, I'm not in BSc Chemistry, but I mean BSc B.Ed Chemistry, but we've had graduating batches in biology and physics. And quite a few students go into teaching after that, right? About 50% of the class, I would say, if I'm not mistaken, basically takes up teaching as a career. And they give there are a few students who have given the exam, the central government exam, the TET, right? And gotten jobs and all that through that. So that is completely that is very focused on um, teaching students how to be the best teachers, right? At the school level. Now, with the BSc Chemistry, the thing is that one is that, of course, you can focus, you can do a very deep focus into chemistry, because it's a 4-year program now. You can do a very deep focus into chemistry. You can actually take chemistry and then take biology minor, you can take physics minor. Then you are very well prepared for research, higher education, other kinds of research-oriented jobs, right? But then, of course, because we have these occupational tracks now, it's absolutely amazing. It's that you have this whole range of options available to you. So like as Rajgopal rightly pointed out, if you do chemistry, and then if you do a media and journalism occupational track, you're perfectly prepared for the world of science communication, right? And there are similar things. If you do chemistry and if you do climate studies, you are very, very prepared to contribute very meaningfully in lots of different kind of environmental spaces, right? Like people who are thinking about, say, decarbonization strategies, right? How do we mitigate climate change? These kinds of think tanks and things like that. So there is the degree is essentially got a lot of flexibility inbuilt in it, right? So I think employability, and in terms of core chemistry employability, of course, as I said, we are giving students plenty of research experience, plenty of laboratory experience, and more uniquely, plenty of computer science kind of experience, through which they can actually become quite employable in different kind of sectors. They have a much broader education. Yeah.
Yeah. And just to add, I think you did cover that in the final year of your study in the BSc Chemistry program. You could either take a research pathway, right? It's a year-long research. Year-long, you can do a research with a faculty mentor, which could be the first stepping stone for your higher education and integrated PhD. Or if you feel, no, I need a little bit more occupational, professional workspace skills, you do an internship in the occupational minor that you would have chosen. So in
Yeah.
that way, the program has that flexibility of also making it a terminal degree leading to jobs like a what do you call like chemical engineer, right? Okay. But this program is unlike a BTech in chemical engineering. Uh, this would open up much more. I'm nothing against chemical engineering. Huh? This will also open up much more avenues uh, that you will decide based on your interest. So how you combine chemistry with the other areas. Yeah.
So if I can just add to that also, I think one thing that, we talk a lot about is our curriculum and our structure. But one thing that you have to remember that I think applies to all the programs in Azim Premji University, and especially to the chemistry program, is that we are a small program, right? So we have 25, 30 students in a batch. So we get very personally involved outside the classroom with our students. The engagement between faculty and student is very high. So even though, say, for instance, you are supposed to start honors research in your third year or fourth year. But most students, they start working with some faculty member or the other in the first year, second year itself. The second aspect of this is that, in other colleges and universities, students who are preparing for entrance exams, right, for masters and all, like say the JAM, the JEST, and all these different entrance exams that you have in India, or even the GRE to go to America or whatever, the people who are preparing for these entrance exams, they have to very often take specialized preparation and coaching. None of our students do that, because the point is that faculty are constantly engaging with them. If some student comes to me after my class and says, I want to prepare for this exam, so for this exam, this topic, where should I study from? I give them the textbook. I have sessions outside class with them to actually help them kind of practice problems and all. And this basically means that our students don't actually take coaching and all that to do these exams. And I think this is a fact that we often overlook, that our class sizes are really small. And so we are able to engage. And even with weaker students who feel that, okay, I don't understand math, or I don't understand this part of chemistry very well, we are constantly kind of, meeting them in small groups or even one-on-one to help them, through each and every problem that we give them. I mean, like we take a problem sheet and work through each and every problem. I think that's an aspect that is not very often kind of considered. It's more important than the curriculum and the curriculum structure. Yeah.
Yeah.
So
There's a question on chemistry in environmental science. If you want to,
yeah.
Of course, as a chemical scientist, you would say chemistry is everywhere.
No.
It's
That's a, yeah. So, of course, chemistry is in the environment, but, so my research is a lot with environmental chemistry, right? So so for instance, the two projects that I actually described, actually one project that I described to you, the one about cigarette smoke, particles in smoke and the lungs, right? That's basically, it falls into this field of environmental toxicology, right? Then this whole thing of using bacteria to clean up water, right? That's also environmental chemistry, right? So we do, there's a lot of overlap. It's undeniable. But there are certain aspects, if you want to study about the environment, where having a chemistry degree really, really helps. Because, so for instance, suppose, a particular pesticide that is being sprayed on crops, how does it actually mix with the soil? How is it kind of propagated through water? We have this problem of persistent organic pollutants, where you have these organic pollutants that are getting into, that are being found in polar bears, or like in killer whales in the Arctic, or orca, So how are these kind of chemicals spreading through the environment? All of that you actually need chemistry to understand. So of course, it's very critical, not just my bias as a chemical scientist, but it's a kind of research that people like me also do. Yeah. And last question, should I, is there?
yeah. Please.
Yeah,
Please.
and yeah, should we do research in chemistry even though we are in a different major? Of course, if you want to do research in chemistry properly, then you must study chemistry, right? But it is possible to use chemistry in research in, like, say, something in biology. Of course, for molecular biology, you need chemistry to understand what's happening inside the cell, right? It is possible. But a lot of things become more accessible and more meaningful if you actually study the chemistry of it at the college level. So from chemistry, you can go into biology quite easily. From chemistry, you can go into, environmental science quite easily. But to come from environmental science and biology into chemistry research is a little bit tough, because there is a lot of fundamental knowledge you won't have, right? But you can, kind of do research in biology from chemistry. The other way around is a little bit difficult. That's all.
Great. What I thought will be a 30-minute short talk, and we'll end up, I think, questions kind of, kept it very, very engaging. Let me ask you one question which I always thought of ask. I mean, the other science disciplines like physics and all have got the specific pillars like magnetism, electricity, optics, da, da, da. Uh, is there anything like that for chemistry? Do you look at it like a physical chemistry, organic, inorganic, or, how does a chemical
Yeah.
science look?
Yeah, so you see in other, if you look at curriculums in any other university, right? If you look at, say, for instance, Delhi University, right? You have, right from the first year, you have physical chemistry, inorganic chemistry, organic chemistry, right? Three different subjects. Even in the US, you start out with general chemistry in the first year, but from the second year onwards, you study organic, inorganic, those kinds of things. Now, when we designed our curriculum, we felt that the acid, it behaves as an acid, no matter whether you study it in organic chemistry or in inorganic chemistry. So why are we dividing it up? So that's why what we have done is actually integrated all three in all of our courses. So our course titles are a little bit different. They look different. So we have a course called Principles of Reactivity. That is basically organic chemistry and a little bit of inorganic chemistry. So we have put different titles because we have actually merged all these three different fields together in a way that is more meaningful to a student, actually.
Got it. Thank you.
हेलो हेलो
Hi.
नमस्ते सर नमस्ते मैम
Yes,
Namaste.
yes.
मैं यूपी ललितपुर से बोल रही हूँ और सहजनी शिक्षा केंद्र से मैंने कुछ स्टूडेंट के फॉर्म भरे थे बीए वालों के
अच्छा।
तो उनकी मीटिंग कब होगी सर?
हाँ जी।
उनकी मीटिंग कब होगी? ये तो आपके बीएससी वालों की है।
तो किसके लिए फिल किया था आपने?
बीए बीए।
हाँ, वो जो पूरा जो लिस्ट जो है वो शायद हमारे में वो एक वेबसाइट का लिंक में इधर अभी डालने वाला हूँ, वहां पे देख लीजिएगा। बीए का कल है, फिलोसफी का कल है, इकोनॉमिक्स का शनिवार को है ना? तो अलग अलग दिन अलग अलग है। तो
जी
तो उसके हिसाब से आप जुड़ सकते हैं, है ना? तो वो जो पूरा जो लिंक है अभी आपको चैट मैसेज अगर आप देख सकते हैं तो चैट में मैं अभी डाल रहा हूँ वेबिनार का लिस्टिंग। ठीक है,
जी सर
मैं डाल
भोपाल
रहा हूँ।
यूनिवर्सिटी
हम ऐसे नहीं कि सारे बीए प्रोग्राम का तो नहीं करने वाले, इंग्लिश का है, इकोनॉमिक्स का है, फिलोसफी
जी
का है ना?
जी
तो आप जोड़ सकते हैं। थैंक यू। कहाँ से आए?
हम ललितपुर से हैं, उत्तर प्रदेश से। ललितपुर
ललितपुर समझ गए। ओके,
भोपाल यूनिवर्सिटी के लिए डाला था मैंने अपने स्टूडेंटों का।
कोई बात नहीं, ये जो है दोनों के लिए है। ये जो
जी
वेबिनार की जो श्रृंखला जो है सबके लिए है। ये भोपाल है, ऑफ कोर्स केमिस्ट्री इज ऑफर्ड ओनली इन Bangalore, but this is for both the campuses. I think on that note, should we, I mean, is there any final words of wisdom that Saswata or Aditi Chandrasekhar would like to share? I mean, they were carefully listening, but
So yeah,
I think they would like to listen
so
to the future teachers.
right.
सर
जान सिंह।
अंग्रेजी में ही होगा कल?
हाँ जी,
अंग्रेजी में होगा क्योंकि हमारे गांव के बच्चे हैं, ग्रामीण क्षेत्र के
दोनों।
बच्चे हैं।
हाँ, दोनों थोड़ा बहुत अंग्रेजी और हिंदी में बात करें, बट मैं ये कहना चाहूंगा, अगर देर आर पीपल लिसनिंग, सी अजीम प्रेमजी यूनिवर्सिटी, द मीडियम ऑफ इंस्ट्रक्शन इज इंग्लिश. It doesn't matter which campus you go to. You may go to Bhopal, you may come to Bangalore. The medium of instruction is going to be English, right? तो इतना तो अंग्रेजी समझना मतलब बहुत जरूरी है कि आपको इतना तो समझे आप on that. But बात करेंगे when you join the BA program thing, we will explain this in much more detail. You know, so yes, Saswata, sorry, I didn't mean to interrupt you.
No,
Were saying
absolutely,
something.
no problem. So going back to the question of can you do research in chemistry department if you're not from chemistry, I will answer it in the reverse. The last department I was working on in doing research was a physics department. So yes, I am a chemist, but I was working on a physics problem, and in fact, I think both Ahana and Aditi will agree that these disciplinary boundaries are very blurry. So we, within the chemistry discipline, have already acknowledged that these physical, inorganic, organic division makes no sense. So we have anyway blurred them out. So, but even in the research field, I'm working on projects which I think will be very accessible to physics students because I work on computation and theoretical development of chemical understanding. So a lot of calculation and a lot of computation that goes on, and it doesn't matter too much how much inorganic chemistry you know for the research that I do. But to apply it, yes, you have to start to learn chemistry. So there's a certain amount of education that is required in the computation and numerical methods, but also we slowly would introduce people to thinking about why we do this particular computation to do chemistry. So that's what I do and work with.
Great. Sounds
Can
like,
I have one more question, please?
yeah, please do.
If there is a time, I mean, I may not be encroaching the time because there are many participants who are already lined up. Can I have a small question? One thing which I want to ask is that about the entrance test. You know that from where one student can get a quality material for this entrance test. Second thing is that is there any particular syllabus for this one? And third thing is that is there any, what is the source from which they can prepare for this test which is going to be conducted?
Yeah.
So and very small thing, please, that either this can be conducted in the physical form rather than the online, because you know that everybody do not have that electronic gadgets or accessibility to these gadgets. So is it possible that this can be conducted in a physical form at the even at the foundation office or somewhere else? Because I'm in a Badmer where foundation is working. So is it possible? Like, so please, can you make it clear?
So this question paper that you need, if you need, just send us an email to outreach@apu.edu.in. We will send you this. There are enough sample question papers for practice on the website. Okay. So
Yes, yes.
there's a lot of sample papers, but we can share that with you also. The
Yes.
entrance test is going to happen in an online mode only. I mean, they have to go physically to a place. It's not like online. They have to have a computer of their own, but the computers will be provided. Yeah, my colleague has put on the chat also the question, does this thing. So yeah, it's going to be they have to travel to a place. Pen and paper में तो नहीं हो सकता.
Okay, okay.
But you don't need access to electronic gadgets either, sir.
That is right.
You go to a test center and then you click on a computer, the test center computer, not your own.
Not my own, I mean at my home.
Yeah. So, and the other thing is that the sample papers that our colleague has shared on the chat, they are extremely useful. Our test is in general in mathematics and English, right? Like your verbal skills and your quantitative skills, and some little paragraph you're expected to write. But there is no domain-specific questions, right? So somebody asked about environmental science or chemistry. There is no subject questions as such. Like little bit of science maybe, but no, like you don't have to like answer questions in chemistry specifically for the entrance exam. And if you look at the sample papers, you'll know this. And if you practice the sample papers, that's really good enough. You should do one before and then do all the practice one and keep one for the end, which you do in a timed way. And that's perfect preparation for the test.
Yeah. I think, yeah, definitely you should practice the sample test papers. And on that note, I think we can close the meeting. And, so thank you, Ahana, Saswata, Aditi did not speak, but and I know thank you for joining. And wonderful questions. Thank you, participants. So we're just warming up. This is first among the many webinars that we do. So tomorrow we'll change our focus towards a different topic on philosophy, politics, and economics. It's a new major that we are launching in 24. And I'm glad that we did this. Ahana, if you remember previously, we used to club this with different majors, and then there's no focus time to talk about a discipline, and when I think about it, I'm feeling slightly guilty. I not feel guilty anymore because we're given enough time to talk only about chemistry. So, so all the best to students who are the examinations, the 12th exams are going on. So do well, and then we'll keep continuing this conversation for the next one more week. So on that note, goodbye and a wonderful evening until we meet again. Bye-bye.
Thank you. Thank you, everybody. Thank you, Rajgopal, for organizing this. Thank you.
Thank you. Thanks.